This compact heater is speeding ahead in the fast lane of espresso machine heating technology. Thick film heater, flow-through heater, or fast-through heater, that's what it's called. And we find it in some of the best espresso machines currently on the market. It's a relatively new phenomenon. And it seems to me that it offers a solution to many of the things we've always hoped to resolve. Faster heating time, better temperature consistency, and so on. How this thick film heater works, where it is installed, and what its strengths and weaknesses are, we'll discuss in this video. In German, this device is referred to as a Dickfilmheiser. In English, it has been introduced as a flow-through heater, or FTH. And it's a small heater, a tiny heating element, almost like it's speeding in the fast lane. Essentially, it's a flow-through heater. It has some strengths. Quick heating, super efficient in terms of energy consumption because it uses very little. Let's dive straight into it right now. But I find it truly fascinating, Michelle. When exactly was the first time we came across this fast-through heater?
In one of our very first videos or test videos of espresso machines that we worked on, so actually quite a long time ago, those were the Sage models, Bambino and Sage Pro. And that's when we had the first points of contact, and then also discovered rapid heat up time gets extremely hot very quickly, temperature. We can discuss that later, but above all, also very efficient in terms of power consumption.
Exactly, that was 2008. In 2018, Michel, the Sage Bambino Plus, was introduced to the market. But I wondered, how does this process actually work? How does the whole thing really happen? How does such a technology then make it to the market? And I delved a bit into the archives, did some research, also asked the manufacturer, got a bit more information, and found it really quite fascinating. There was this initial model from them already in 2007.
Wow.
That was specifically developed primarily to reduce pressure and was mainly utilized in pad machines for that precise intended purpose. But essentially, there was the first FTH, flow-through heater, by the company called Pharaoh, which we'll talk a bit more about shortly, in 2007. In 2013, this company began selling starter kits with this assembly, which around 100 international companies purchased to integrate this heating element primarily into their machinery and systems for various industrial applications. The hot water they need or are supposed to produce, on one hand in kettles, of course, and then also in espresso machines. And this new model can handle up to 15 bar or process 15 bar. And that was, of course, a prerequisite in the first place, because we naturally need pressure if we want to make espresso. And then there's always a pump attached at the back, and these things, of course, need to be ready for that. And one, I would say, the very first mover in the complete history of this story was undoubtedly the company Sage.
Breville.
Yes, and one of the first machines, or the first one that we then looked at with this technology, was the Sage Bambino Plus. Do you still remember the test? I was genuinely amazed by how incredibly fast that machine heated up. It was there in almost no time.
And it also had amazing steam power. That's something to keep in mind as well. So that was truly very impressive to witness firsthand.
And what we then observed about the machine is that it had its weaknesses when it came to maintaining a consistent temperature. The Sage from Bambino Plus managed it quite well, to be fair. But back then, another machine, also from the same manufacturer, was performing just a little bit better. That's Breville, I believe. Outside of Europe, or at least beyond the German-speaking market, the machine is primarily sold and marketed exclusively under the name Breville or by the brand Breville. Here it's Sage. And the other machine that came along, also with the technology, that was interesting. We first took a closer look at the Sage Barista Express and then the Sage Barista Pro. And Michelle, it was a bit more consistent in temperature. I think we genuinely had a lot of fun with that one too. We made some videos back then. I think we should do another one soon. Because, interestingly, from my perspective, it's still one of the best with film heating that we've seen and tested over the years at Sage. Even now, it holds up remarkably well. Quick to heat up, and relatively good in temperature. We also criticized a few things in the basic assumptions and so on. But the two, and we want to make this very clear here, the company Sage is the trailblazer of a technology that subsequently paved the way for numerous other machines to adopt, develop, and significantly expand upon this groundbreaking innovation, which, in my opinion, have done many things very well and have even surpassed Sage in terms of consistency and other aspects. But perhaps we can briefly discuss how this model, how this thick film heater works, and take another look at the comparison. why it's different, and why it might surpass the boiler in certain aspects. Before the thick film heater, a quick detour. What are the other two commonly utilized elements that are typically employed for heating water throughout the entire process of brewing espresso? There's one that's completely different, and there's one that's a bit more related.
Yes, absolutely. We have the boiler, which you all know. So in terms of size, we often have dual boilers in machines, which might be slightly smaller, you see. There we're somewhere around plus or minus 1 liter or a bit less. And with heat exchange systems, we're often working with 1.6 to 3 liters in the largest possible configurations. With gastronomy machines, it's often 8 or 10 liter boilers. And there we have a heating element inside, which essentially heats up the entire mass, in this case with a heat exchange system featuring a heat exchanger for the second espresso circuit. That means we have an enormous amount of standing water. So when we're talking about 1.6 liters here, it's filled up to somewhere just under 2/3, minus a bit that's still in there. But that's somewhere around 7-8 deciliters of water, which always has to be kept hot for the brewing process, or more specifically for generating the steam.
Exactly. On one hand, it always has to be hot, and first of all, it naturally has to be heated up. That means it takes a long time, and we consume a relatively large amount of energy just to end up boiling, let's say, 800 milliliters of water in the end. They're not always completely full. To end up heating those 800 milliliters just to brew an espresso, and if you're making a double espresso now, a double espresso in the cup ultimately amounts to just 45 milliliters in total. What you actually use for brewing water is around 80 to 90 milliliters, yet you've heated up 10 times that amount. And that already shows it's actually not an efficient technology at all. To some extent, the heating process isn't even entirely direct or straightforward, which adds to the inefficiency. And that takes time and consumes a lot of energy. And we can say today that with such a model, we often have double, triple, or even quadruple the energy consumption. Compared to what the fast-through heater ultimately needs, there's a slightly more pragmatic, faster solution, which in a way could also be the precursor to this other technology. That's the thermoblock.
It's often, in fact, an example in fully automatic machines. And there's also a slightly different design for the portafilters, for example, for the Espresso. And there we have just about 300, 400, 500 grams of aluminum, once a run in a circular pattern, or rather in a spiral pattern. And on the other side, we've got the heating process in place. And just by doing that alone, there's a whole lot less standing water compared to over here. But still a certain mass that you have to heat up significantly.
However, no standing water either. It's essentially a flow heater as well. Only here, this aluminum block is heated, and it naturally affects the water flowing through, but it still has significantly more mass overall. I'm saying it correctly here. Than this thin, super thin metal sheet here, which isn't even 3 millimeters thick, right?
We also have an extremely minimal amount of water here that we're heating, since there's practically no water available, just the exact amount we truly need for this particular task at hand. And because of that, it's practically instantaneous, just 1 or 2 seconds to reach boiling point, and maybe an additional second or two to fully transition into producing steam. But essentially, just press the button and it's instant. Brewing potential, in theory, right there.
We basically have these pipes embedded in this substrate, stainless steel housing, and that's also where these heating elements run directly through. The heating elements connect directly to the energy source. When energy flows, the temperature's there, Michelle. And at the same time, we also have the temperature sensors in there, and you're absolutely right. The heating time, it's instant. We observe the transfer and the temperature, even within the brewing head. You can also incorporate other elements there. Of course, the rest of the machine doesn't get instantly hot straight away, but the water is hot. Yet that doesn't mean the portafilter is hot yet. And with that, the brew group is likely not hot yet. None of that is hot yet. That means we always have some waiting time there. That's why it still takes a certain amount of time with some machines. Let's say the Zuriga takes 2 minutes or the Maro takes 4 minutes until they're hot. And those in turn are different models, which we'll also get to in a moment. But that's essentially what this has managed to accomplish.
I also see another advantage, which of course the thermoblock has as well. We can handle the descaling ourselves. So we have very little limescale buildup in general. Of course, there's some risk involved because the pipes or the tubes, if you consider it, are extremely narrow, delicate, and prone to clogging over time. If there are tiny particles in the limescale, descaling is required. But you can also handle it yourselves on a regular basis. We'd always recommend using soft water for espresso anyway. But here, I would still suggest doing a descaling every 3-4 months. Depending on the machine and the manufacturer's recommendations, then you're completely set to go.
Yes, but of course, we can say that now. With the models we have, with the machines we have there, and especially the first ones we looked at back in 2018, 2019, they don't have any calcification issues, number in that sense. And in this channel itself, an NTC sensor is embedded, which in turn measures the temperature, and that needs to be controlled. And we get to that by also continuing to tell the story a bit further. Again, truly fascinating. There's a company called Ferro Techniek, headquartered over in the Netherlands. Around 50 at the headquarters, plus additional factories. Then there are another 80, and they belong to a larger corporation called the Otto Group. They are actually responsible not just for the thick film heaters that are in these two devices we've already looked at, but then more and more espresso machines started appearing on the market that utilized the technology and also enhanced the control aspect, making the machines more efficient and much easier to use over time. And the very first ones we reviewed who successfully implemented it in their operations were companies based in Switzerland.
Yes, absolutely, because they have a control technique in there that really works great. That was the Zuriga. And that was the first time we were truly amazed because, and I really have to say this, it was the first time on our test bench that we had a machine with this technology, which is firstly super quick at heating up and impressively efficient. We're literally talking about just 2 minutes, and it regulates the brewing process so consistently that it produces absolutely incredible espresso every single time.
And there are actually two essential components for that, dear Michelle, specifically a second thick film heater that sits at the top of the brew group. Essentially, if we take a look here, a second one is positioned up there, ensuring that the portafilter gets heated up relatively quickly and efficiently every single time it's used. And the other magic word is, as you rightly pointed out, effective control of the energy being introduced in relation to the flow and in relation to the amount of energy that's actually being utilized in the process. Heats the machine up not only quickly but also precisely, and we've delivered amazingly good results. And the machine we're talking about is the Zuriga in Generation 2. Nice, compact, handy, super fast heating. Yes, we've discussed it. You can watch the video about it. I think this is really proof or evidence of what the technology can actually do, where the potential lies, and how this potential has been utilized in other machines. And it's not just espresso machines, of course. But I just want to briefly mention, for example, the tone filter coffee machine relies on thick film heaters, or even the Iden Precision Brew, another device that's designed to. Brew filter coffee also uses a thick film heater. And then we come to, I would say, the machine that has done it the best so far, the one that most consistently handles the entire heating issue and is also the most precise when it comes to maintaining temperature control, and that is the Maro. We can't conjure them up. No, we can't magically create them out of thin air. We'll just superimpose them for you now. The Maro, as you all know, we've also tested it. Also a machine with thick film heating.
Exactly. Because it was understood that while the thick film heating itself is a very simple technology, not insanely expensive either, it demands a precise control system to function effectively behind it. That delivers this speed, this instant heating with precision, which brings us to 93 degrees. Maintain a steady temperature level that reliably brews great coffee.
Yes, and we see that in the machine. You can also see it in these curves, which we're now displaying here. But you can clearly observe when we take a more detailed look at the curves from the machines developed several years before, they weren't nearly as precise. And we have to say, even today, and I think it's quite a phenomenon, Sage has been somewhat surpassed. Even if we look at the new Sage Oracle Jet, that one too is equipped with a thick film heater, and we have to say it just works much better nowadays. So there are simply machines that handle this more effectively. And yes, I truly hope that Sage, as a pioneer and leading integrator of this technology, catches up, reconnects, and solidifies its strong and influential position in the market once again. And we will see more machines. So this is not the end of the journey here, but this year, the Roxy is coming to the market, the Nunk is coming to the market. And perhaps there's one or another machine that we're not yet aware of, and maybe you've already caught wind of it. And if you've heard about it, feel free to write it in the comments, or take a look at the detailed blog post where I attempted to figure it out, which machines came to the market when this technology evolved. And I'd be happy if you could help fill in the gaps here. And maybe you'll even find other companies that developed the thick film heater or similar technologies. We're keeping our eyes wide open, and we aim to use our channel to make those market shifts visible. We're always truly thankful for any tips or insights you might have to share with us. Also, regarding new pumps and so on that are coming out, that's it for today. We're now having an espresso with the Zuriga and later a filter coffee with the Tone, raising a toast to an innovative technology that sets entirely new standards in energy efficiency and heating speed, potentially ushering in a groundbreaking era, namely the fast-through heater century.
Lunchtime. How do I do this with the cable? Just throw it back, or we're still in the same spot. Perfect.
To Riga in Generation 2. Don't move. Maro is next. You'll have to. I'll tell you. Stay and say, go get them now.
Being it's still dirty. Ben, didn't you clean it up properly?
Yeah, just the top. Just leave.